So, and it makes me mad, hurts my feelings, it's everything. So you be on the lookout because now I'm mad and you're gonna pay the price. I'm sorry, that's just how it is. All right. Let's. All right, let's do this. Okay, so the question is, just like it was on your test, draw a sketch of it, and then tell me the amplitude, period, phase shift, vertical shift, and frequency. Okay? Now, some of this, in fact, maybe all of this, you can tell me before you graph it. You should be able to look at that equation and tell me the amplitude is, what's the amplitude? 3. Are we ever going to say the amplitude is negative? No. Never going to say that. There's a negative number out there, and that will impact my graph. But it's 3. All right. How about period?
5.
Because the period is always 2 pi divided by that number. All right. How about phase shift?
Minus pi over 8.
Negative pi over 8. Which means when I get around to drawing this, my sine curve is going to start right there. How about vertical shift? Yep, we don't have one because there's no number on the end. That would be where my vertical shift was. And then frequency is reciprocal of period, so 1 over pi. Now, I want to talk about that for a second. If, let's say we had a different picture, and the period was 3 pi over 7. The frequency would be 7 over 3 pi. Frequency is reciprocal of period. So, the whole thing gets flipped over. All right, so here we got all the stuff. Now we're going to sketch it. It is a negative sine curve. All right? So a negative sine curve is going to go down and then up. Right? And now I need to know all of these important points.
The right point, 7 pi over 8.
So, if the period is 8/8, 1 pi, 8/8, then this point is going to be negative 1 plus 8, so 7 pi over 8. This guy is right in the middle of negative 1 and 7.
3.
The midpoint, the average of negative 1 and 7 is 3. Because negative 1 plus 7 is 6, divided by 2 is 3. So this is 3/8. This is going to be the middle of negative 1 and 3. So negative 1 and 3 is 2, divided by 1, or divided by 2 is 1. And 3 and 7 makes 10, divided by 2 is 5. Problem finished. All right? So I'm keeping track of all of our review problems. All right? All right, let's get our notes out and continue our
What'd you write?
conversation. right, and this is Jake Gardner, and this is Caitlin. This is London, Grace, Aiden. Okay, here we go. Somebody emailed me last night and said, oh, Mrs. Ford, this is so confusing. You know what? Practice makes perfect. So let's focus. That means Sam and Dana, whatever you're talking about, stop it. Get your notes out, pay attention. Ronan, get a little less comfortable. Let's get focused in. We are solving, and we're solving between 0 and 2 pi, which means my answers will be in radians. Okay, now let's look at this equation. How do you solve something that says basically x squared equals 3? What do? What? Root it. You square root it. And when you square root it, it's going to say tan x, be careful, equals plus or minus the square root of 3?
Yeah.
When you take your square root, it's always plus or minus, because every number has 2 square roots. All right? What we'll learn in chapter 6 is that every number has 3 cube roots, 4 fourth roots, 5 fifth roots, and so on.
And emergency.
All right, back to the matter at hand. Somewhere there is an angle, and its tangent is either positive or negative. Now wait a minute. If the tangent is positive or negative, it's everywhere. Right? It's tangent in quadrant, or it's tangent. It's positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4. So this problem's gonna have 4 answers. Now here's the good news. If the tangent opposite over adjacent is root 3 over 1, then how big is my angle right here?
60.
60, but I'm in radians,
So pi over 3.
so pi over 3.
Nice having
All of these triangles are exactly the same. So once you figure out that's pi over 3, it's pi over 3 for all of them. All right? Now, what are the actual answers then?
pi over 3.
Well, pink will be one answer, and it is pi over 3.
Next one is
The blue will be another answer.
5 pi over 3.
2 pi, or pi
5 pi
minus,
over 3.
pi minus pi.
This is 3/3.
Yo, it's
Right.
pi.
This is
2
3
pi,
thirds.
2 pi over 3.
So won't the blue be 2/3?
Yeah.
Pi minus a third, 1 minus a third.
And it's 4 pi over 3.
And then the green
4 pi.
will be that answer, which is 3/3 plus another third,
Yeah.
4/3. And then the red, remember, this is 2 pi or 6/3. Did I go all the way around? No. I didn't go 6/3, I only went 5/3. So there are your 4 answers. So that was a really easy problem. But you had to make sure you got an answer in every quadrant. All right, let's look at the next one. Before you can start figuring out your
Minus the
piles or
sign
whatever,
already equal to 0.
you gotta figure out how you're going to.
Get it equal to 0.
Where am I? Oh. So, first thing, what'd you say, Jay?
Minus the sign over. get
No,
it
you
equal.
divide the
Let's-
sign over.
Or divide.
Divide the sign over, Jay.
Stop. Let's talk about that.
Guys,
I think you minus.
yeah, you divide it.
No, this is a really big deal math thing, all right? This is a really big deal, so I need everybody listening. Dana said, we're gonna divide both sides by sign. Now, I know that if you had a problem like 2x equals 6, you would divide both sides by 2. I know you would do that, and that's okay. But you can't ever, trigonometry, logarithms, exponentials, anything. You can never divide by an x. An
Factor
unknown.
down.
Because you don't know, it's an unknown. You don't know what it is.
Zero.
It could be 0, and if it's 0, we have trouble. So never, ever are we going to divide. All right?
You factor out.
You can divide by 2, you can divide by a negative 18, but you can't divide by anything that has an x in it. All right? The idea was good. Let's get that sign out of there. Well, you can't divide by it, so we will subtract it. Now that is perfectly legal. All right? What do we do once we get it moved over?
Factor.
We can factor out a sign.
Come on.
Oh.
And remember, when you factor out a sign, you're gonna be left with tangent squared minus 1.
And then you get those equal 0.
We separate them, so sine x equals 0, and tangent squared equals 1. So tangent will be plus or minus the square root of 1, which is 1. Aiden, did you have a pass?
Huh? No. I was helping you set up the camera.
All right,
I believe it.
all right. I know he is.
You want me to take a photo?
Oh, yeah, that's like
A lot.
dress code.
Yeah. That's crazy word.
All right, now, you are not done, because your job is to do what we just did here. You have to actually find the angles, all right? So, where does the sine equal 0? Now, you aren't gonna be able to draw a triangle, because opposite over hypotenuse can't be, you can't have opposite be 0. There's no triangle with a 0. So instead, we look at our circle. And if we're doing sine, we're looking at which coordinate, the x or the y? Y. So where is y 0?
North and south, but it's.
Right
it's the
here?
west.
Y is 0? And over here? So 0 and pi. Aiden says 0 and pi, and he's exactly right. 0 and pi. That's where sine is 0. Now, I got this plus or minus thing going on again. If tangent can be positive or negative, aren't I gonna be in every quadrant?
Yeah.
So I'm gonna have an angle in every quadrant again.
It's gonna be 45, 45, 90.
And the tangent is 1, which means the angle is 45, but whoa, I gotta be in radians.
Oh, 5 or 4.
Five.
Pi over 4.
Nice.
So I need all 4 angles again. Obviously, the first one is pi over 4. Now remember, right here is 4/4. That's 4/4. So this one would be 3/4, and this one would be 5/4. And then this one, remember, this is 8/4, this is 2 pi. So if that's 8/4, then this one must be 7/4?
Yeah.
Whoa.
Now, if we were in degrees, that would be 45.
Yep.
This would be 180 minus 45.
Yep.
This would be 180 plus 45. And this would be 360 minus 45. Right? All right, one more. Not with those directions. Our directions were 0 to 2 pi. Those are all positive numbers.
So if it was 2 pi to 0.
It can't be 2 pi to 0.
Hey.
It could be negative 2 pi to 0. Those would be negative numbers. When you write an interval, it has to be zero. All right, here we go. One more. All right, my friends.
Factor out the 4
Minus 1.
cosine.
Minus can't. Oh, you can factor the 4. No, you
The
can't.
four-
No,
no,
you
you
can't.
can't. You can't.
Subtract 1 and 1 in the third.
Oh,
1 and 1.
And then
Take the
Joe,
4 out, factor.
let's just take Joe's thought for a moment.
Stop.
What would I, okay, so Joe, you want to subtract 1, okay?
Yeah.
Then what would you do?
Factor out the 4 cosine.
Yeah.
Okay, don't write this down because it's all wrong. But
Oh.
Let's
Yeah.
talk about it.
There was a little bird in my
This is
ear.
something, this is an algebra issue, and kids try it all the time. So they say, okay, I can factor, okay, great, I can do that.
You can't factor by 0. You can't divide by 0.
Can't go into
But now what would you
You have
do?
to divide by 0.
Remember, at this point, you're supposed to break it apart,
Yeah.
but you can only break it apart if it's equal to 0. So you have done no wrong math. This is all absolutely correct.
Oh.
But at this point, there's nothing to do. You're finished.
That's not what
You can't
That
solve
was all
it.
Oh, but there's
You
nothing.
just have 4 codes.
Can you factor out a 4?
4 codes.
Just a 4. And then you get 1 4.
No.
No. There's no
And then you get
4.
cosine squared x by 2.
Okay, so wait a second. Ronan, stop. So you want me to factor out 4,
Come on, man. Squeeze.
okay, and then do what?
Are you saying we should?
That part I don't really know.
Yeah, so because there's nothing to do, that's the problem. When you get there, there's nothing to do because the whole point of factoring, is to set each one equal to 0. And you can only do that if this is, so the minute you move that 1 over,
It's not that easy.
I think Jake said he had.
No, I know,
All right. I saw a hand, I thought.
Yeah, it was Jake
But I don't
said.
wanna say, cause
Yeah, say it.
no, cause it makes 0 sense.
There's no bad answer in math. class.
There, okay,
They don't
That's not
equal to
true.
each other.
okay, so this is what
Airball,
we're gonna
airball,
erase.
airball.
Hey, think about this for a second. What if this equation were 4a squared minus 4a plus 1 equals 0?
The Pythagorean.
That's a quadratic.
That's a quadratic.
Oh my god.
Wait, what did you say?
This is a
tell me.
quadratic equation.
Oh my
Now,
god.
Who did it?
what do you do with quadratic equations? You can always use the quadratic formula.
Right on that board, just put it on.
Or
Negative
you
b.
can try to factor it into 2 parentheses. So if this had been the problem, let's factor this, pretend we're freshmen.
2 and 2.
We're factoring 2a and 2a minus 1 minus 1. Isn't that the way that would factor?
Yep.
Yes.
So how will this one factor? 2 cosine minus 1,
2
2
cosine.
cosine
Plus 1.
minus 1.
Oh.
When you FOIL
Wait.
that back together, does this give me 4 cosine squared?
Yeah, it should be a negative.
Minus 2 minus 2 gives me negative 4,
Oh.
and negative 1 times negative 1 gives me 1.
Put Molly on her.
All right, it's a factorable quadratic. So now I still have 0, so now I can set them equal to 0. So it looks like cosine equals 1/2. Now, this one, because these match, will be exactly the same. I don't need to do it again. Usually when I factor, my parentheses are different, so then I would solve each one. But this time, that's going to be the same thing, so I'm not going to do it. So, where is the cosine positive? 1
1 and 4.
and 4. Cosine is positive in 1 and 4 because cosine is x, and x is positive on the right side.
Yeah.
Yep.
Now, adjacent over hypotenuse is 1/2. So this is a √3, and the angle is
60.
Pi over 3,
60
pi over 3, pi
in
over 3.
radians, pi
Pi.
over 3.
Over 3.
There's only 2 answers. One of them is pi over 3. And the other one would be all the way around.
Yeah, 5
And those are the 2 answers to the problem.
Not gonna lie, that's pretty easy.
Okay? All right, now get your calculators out.
Ooh. That's where you did me.
I am to answer in radians and degrees. So, Peyton, you want to do, or Pat, do you want to do this in degrees or radians first? Degrees. All right, so we're going to set our calculator in degrees. In a minute, we'll have to change it. We have to do both, so it doesn't matter. We'll just do degrees first, because he wants to. So what do we know? We know that the cosine equals 0.37.
Yep.
Now, a minute ago, I did this problem without my calculator, because the cosine equaled 1/2, and that's special. I do not have any idea
Where this goes.
about sides that are 0.37. I don't know about that. But I do know it's positive. And because it's a cosine and it's positive, aren't I gonna have those 2 answers again?
Yep.
Right?
Yep.
Now, I'm gonna use my calculator. What do I type in? Second cosine, 0.37.
Yeah.
68.28.
Yeah.
And then 360 minus 16.
So one answer will be the 68.28. And then like Dana said, the other one will be 360 minus that, or 291.72.
Do we put degree sign on
Yeah.
And then
Now,
have
you
radians.
guys, shh. What you just did is exactly the same as we did over here, right? Everything was the same. We just used our calculator to get the angle because we needed to. All right, now we're gonna do the same problem in radians. So all you need to do is go to mode, change into radians,
Radians problem.
and then second cosine, 0.37. And it's gonna give you that angle, which is 1.19.
Yep.
So in radians, we're 1.19. And then how will we find the other one?
2 pi.
2 pi minus 1.19, 5.09.
5.09.
So if I'm in degrees, I'm taking 360 minus my calculator answer.
Yeah.
If I'm in radians, I'm taking 2 pi minus my calculator answer. Okay? Now, would you try number 6? Do exactly the same thing,
No.
except this time, our angle is, or our equation is tangent equals 5. So you're gonna do it in degrees and you're gonna do it in radians.
So we're looking for the y, that's positive.
positive, so it's in the first one. It's in all four, right? No.
No.
It's tangent, so it's positive. You know which ones?
Where's tangent positive?
Oh, it's 1 and 4.
1 and 3.
1 and 1 each side.
1 and 3. So your answers this time are gonna be in 1 and 3. Tangent is y over x. Here, they're both positive. Here, they're both negative. Any other combination is not going to come out positive.
I'm a killer clown. What's that thing?
What do you left at?
I want to laugh too.
Stop it.
I'm sorry. Wait, how do you get that? Wait, what did you type on your calculator again?
So we got. Whoa. Oh yeah, we got. Where's that? 0.7? Is it 78.7 plus 180? And then 78.6 now. That's 0.7. Rounding up. Because look, this goes up to oh wait, never mind.
Yeah.
No, it's because the last typed it wrong.
Yeah, I typed it in wrong. How did I type it in?
Okay. So is everybody, do you get why it's quadrant 1 and 3? So when you do second tangent 5, if you're in radians, you get 1.37. If you're in degrees, you get 78.69. When you just type in the button, second tangent 5.
Yep.
Your second answer will be all the way over here in quadrant 3, which is pi plus the first one.
Yep.
Or 180 plus the first one, depending on if you're in degrees or radians.
How did you
The directions say do both. I would imagine on test day it'll be one or the other. Okay? All right, 5-1 homework will be due on Monday. All right, so 5-1 due on Monday.
We don't have an e-learning yet.
No, you can do it for e-learning.
Yeah, that'd be already enough.
We don't have your class.
I know, so you can do it
No,
on,
but
you
he
can
can
do
do
it on the weekend.
No,
You can
that's
do
what
it
you
tonight.
do.
I don't have class tomorrow. Zach told me.
I don't know when you, it doesn't matter to me.
As long as you get it in on
Today's Thursday,
What to do?
Friday is a school day. Do Monday, okay? Period.
Period.
You're not gonna do it anyway, so what difference does it make?
You're right.
All right, here we go. 5-2. We do have office hours on Monday. For those of you that can manage to get to school by 8 o'clock.
Joe.
Tyler. All right, here we go.
Joe Garber's gonna leave that office out.
Did you get 1% better than that?
She has master's all the time.
5-2. Verify the following.
Okay.
Now, what that means is that you need to simplify one side into the other side. So, yesterday, we did problems that said simplify. Do you remember?
Yeah.
We messed around with them and we boiled them down to something, whatever we ended
Whatever
up
it was,
with.
yeah.
Today, we're doing the same thing, except you know what your end goal is. You need to simplify this, and eventually, it needs to come out to be signed. All right? Now, Elijah's up here coming unglued because he's seen the numerator is 1. So we have 1 on the
1
top.
over 1 cosine.
Now, why is the numerator 1? Because sine squared plus cosine squared is 1. That is a fact. It is on your sheet. All right? Now, 1 over something means reciprocal. Like 1 over 4.
1 over sine.
1 over 4 is the reciprocal of 4, right? So this
1 over sine.
is the reciprocal of the cosecant. What is the reciprocal of the cosecant?
So it's correct.
So you just verified or proved that this will boil down to sine.
Oh.
All right, let's look at the next one.
Should this be close to? Money talk.
Tangent over secant is supposed to equal sine. All right, here we go.
Then 10 times close.
What is tangent?
So 1 minus 2. Oh, wait, 1
Use your sheet.
Tangent is sine over cosine.
Sine over cosine. So this is sine over cosine. Over, what is secant?
Secant is
1 over cosine.
oh.
So guys, just like 1 over cosecant is sine, because they're reciprocals, 1 over cosine is secant, they're reciprocals. That's what reciprocals are.
Oh, this is right.
Now, this is a division problem.
Opposite flips.
So I will write my numerator, I will keep my numerator, I'll change the division to a multiplication, and I will flip my denominator.
Sine x.
In other words, I am multiplying by the reciprocal. That's what division of fractions is. Well, what happens?
It's verified.
They cancel and we're verified.
It's verified.
We got sine, we were supposed to get sine, perfect.
Number 3 was tricky.
So again, this is exactly what we did yesterday, except now I know when I'm done. Now I know what I'm shooting for. So it's actually easier than yesterday. All right, let's look at the next one. Okay, it looks very big. Without all talking at once, let's be calm. Does anyone have any ideas about how we might proceed? What could we do over here? Ronan?
Cosine times the tangent equals sine.
So what Ronan is doing is, he's saying, okay, what this right here is sine over cosine. Right? And I might as well do this one too. So this is sine times what's cotangent?
1 over tangent.
What else is it? Yes, it is, but what else is it?
Cosine over sine.
Cosine
over
over
sine.
sine.
It's the opposite.
Something like that.
It's a reciprocal again. I see
So,
that.
I love this.
Picking up.
Somebody looked over here, this is our end goal, and said, wait a minute, there's no tangents in that, it's all sines and cosines. So let's change our tangent into sine over cosine,
I see.
and our cotangent into cosine over sine. Now, I'm gonna distribute,
That cancels out.
so I have I'm gonna write it out, but yes, it is going to cancel. And then I'm gonna multiply this one, cosine times all this. Alright, so nobody gets confused, we're taking cosine over 1 times this, and then cosine over 1 times that.
Then do the third one.
So what happens?
Those cancel out.
These cancel and leave me with sine. These cancel and leave me with
Cos squared.
cosine squared.
Oh, that's the
And
answer.
lo and behold, isn't that exactly?
Wow. Wait, so what is it, so what do you just have to show that?
So this, and then you should be correct, completely correct is, your job was to prove this, so you
No.
you showed that the right side and the left side are equal. They're the same thing. Basically, what you're doing is you're simplifying this and ending up with that. All right, that was easy. Okay, what about number
Play down.
4?
Play down.
All right, so just before you shout things out, take a moment, take a breath. What might be something
Sine over
to
cosine.
this?
And equals sine over cosine.
Plus 1 over.
I know.
Minus 1 over cosine.
Let me block everything.
All right, so I heard some stuff that actually was good stuff.
Sine over cosine.
This is sine over
That was all
cosine.
me, by the way.
That was not.
No, it's not. I think plus everything.
And what's secant?
Tangent. 1 over sine.
Stop.
1 over cosine.
Whoever said tangent.
It was Ronan. 2 over sine. 2 over sine.
Okay, so Ronan.
No, I forgot, there's a 1 in front. I didn't see it.
Plus they're squared.
Yeah.
So the Pythagorean, what are called the Pythagorean identities are awesome, but they're squared. So 1 plus tangent squared is secant
I
squared.
thought you could just remove that.
You can't just remove the squares. No, they're squares.
There's 7 o'clock.
Secant is 1 over cosine.
Block it. Okay.
Now,
You have a common denominator.
we already have a common denominator, so we can go ahead and add
Cancel those
these.
out. Cancel that, yeah. Wait. Oh, yes, right, yeah. Okay, now what do you do?
So, this is where I'm going. It's my goal,
Raise the foot upside down.
and this is where I am,
Step
right?
in first. Cancel.
You can't just flip things over. Your job is to do something here that's gonna turn it into that.
Square by -1.
So I want you to think about something for a second. This is what I have. That's what I want. So
Pardon the interruption, but remember at this time, we'll prepare for the wrestling send-off. Educators, please check your email for details.
Are we serious?
Yeah, we can. Oh my god. For you, Mr. Ward.
Dang it.
wait a minute. Let's.
We're not gonna
let's-
go yet. Let's finish.
Let's,
And they're gonna stay every
let's
year.
at least talk
Let's just
about,
finish this. Finish it all.
Like,
let's just talk about what I just
We
did.
usually don't finish.
I was keeping an eye on where I was going. Where I'm going is here.
In first.
This has a cosine in the numerator. This does not. So I put a cosine in the numerator. That is completely legitimate as long as I also put one in the denominator. Okay? So we got to this point and Dana said, where do we go from here? And you're right, this is kind of a dead end. So then I gotta get creative. I need a cosine, I'll give you a cosine. But now, I have cosine over sine plus 1 over cosine squared.
Yeah.
Do not cancel, because that will just bring you back to where you just were. Look on your sheet. Cosine squared is 1 minus sine squared.
Yeah,
There we go.
Where does it say that at?
on the paper.
Oh, I see it. 1 minus 2 sine squared equals 2 cos squared.
You're looking in the wrong spot. Sine squared plus cosine squared is 1, Dana. So cosine squared will be
Oh,
1
you
minus
cancel out the
sine squared.
signs and you'll.
Show me where you see that. Where that-
You can't cancel yet. This factors.
Oh, it does.
This is the difference of squares. And once you factor, then you can cancel, and look what you end up with.
I gotta take the test.
That makes so much sense.
I get it.
No, it doesn't.
On a scale, we're gonna go down and stand in the Mary area, but on a scale of 1 to 10, this problem right here was like a 2. This problem right here is like a 9, all right? This is a tough one. This is a tough one. But now I've given you some ideas about, okay, if I'm stuck, let's put something in and see what happens. Okay? So everything, we're gonna leave everything here, I think.
Oh, yeah, what did you
All right, you gotta leave your phones and backpacks here.
Yo, this is going on.
No phones, backpacks, stay here. What do you need?
Phones up. Bag still
Bring
here.
them
Phones
outside.
up.
We're down in there.
Wait, can I put my phone out?
Yeah.
Bro, because everybody was
Down in the area, let's go.
there would be no one not playing for
Down in the area, phones and everything stays here. We don't need the video in the classroom for a while.